All right, welcome everyone. I am absolutely thrilled you're here for this explainer because today we are tackling something that is a real game changer. We're diving right into episode 3, breaking the bottleneck, architecture and code data locality. This is all about a profound architectural shift in software engineering, driven by the rise of hierarchical script databases, or HSDBs. You know, if you've ever found yourself wondering why massive cloud applications just suddenly grind to a halt, driving your server costs through the roof and absolutely crushing performance, or why we spend so much sheer computing power just moving data from point A to point B, well, you are in the exact right place. We are going to break down exactly how uniting executable script and data properties right at the root level completely solves this bottleneck. Okay, let's dive right into this. To really anchor these dense technical concepts, I want to start with a brilliant analogy from Kyle Smith. He's the creator of the patent-pending SeedTreeDB. He basically describes traditional database systems as having this bizarre linguistic divide. So imagine if the English language kept all its nouns, the data, the objects, in one room, and all its verbs, the instructions, the logic, locked away in an entirely different building. To even communicate, you'd literally be running back and forth over and over just to form a single sentence. And honestly, that exhausting back and forth, that is the exact core problem we are solving today. See, for decades, standard system designs have basically relied on this fully decoupled architecture. You've got your state, your data, safely tucked away on a physical storage disk, and your compute, the logic, running on a totally separate application server. And this separation creates a really rigid boundary. Every single time your app wants to do anything, it has to fetch the data across a network, translate it, process it, translate it back, and then send it right back over that network again. It is a massive and honestly really expensive waste of computing power that creates these severe network and serialization bottlenecks. Well, HSDB flips the script entirely by achieving total coupling. The logic and the data actually reside together in one single kernel. So, here is our roadmap for the explainer today. We're going to start with a great database divide. Then we'll hit nouns, verbs, and locality. Next up, we'll actually peek inside an HSDB node before unpacking the concept of structural isomorphism. Then we'll see how LIFO guarantees absolute truth. And finally, we'll wrap up with how this completely eliminates the network bottleneck. Starting with part 1, the great database divide. To really get why this matters, we need a tiny bit of history to see where these massive latency bottlenecks even came from. Interestingly enough, we actually had this right way back in 1966 with MUMPS. That was a system built for hospitals that brilliantly integrated a programming language directly with a hierarchical database. But, over time, the industry kind of drifted. By 2009, we saw the explosion of decoupled NoSQL stores like MongoDB. They scaled horizontally for sure, but they totally separated logic from the disk. Then, by 2014, we hit the absolute extreme end of decoupling with serverless computing, where compute is just totally ephemeral and state has to be offloaded completely. Finally, around 2020, we see the pendulum swing all the way back with the patented HSDB architecture, synthesizing the absolute best of both worlds. Seriously, when you look at the sheer density of a standard MongoDB aggregation query, it's wild. In standard decoupled systems, developers have to build a database schema, an application logic layer, and then this incredibly complex query layer that basically just acts as a mediator in between. In the industry, this is famously called the object relational impedance mismatch. Basically, you need these heavy driver libraries and massive parsing overhead just to translate your application's logic into something the database storage engine can actually understand. It's friction, pure and simple. Which brings us to part 2. Nouns, verbs, and locality. Let's look at the elegant architectural fix for all this. Building on Kyle Smith's analogy from earlier, in standard designs, your database schema is your noun, your application logic is your verb, and your query? Well, that's that clunky, slow mediator trying to introduce them to each other. HSDB just finers the mediator. By utilizing JavaScript as a single homogeneous language for both data retrieval and scripting instructions, HSDB places the nouns and verbs right next to each other in cohesive structures. By totally eliminating that mediator layer, you directly solve the friction of serializing and dragging data across networks. Let's move to part 3, inside the HSDB node. Let's pull back the curtain and look at the actual anatomy of what this looks like under the hood. Instead of static rows and columns or passive documents just sitting there, an HSDB is made entirely of active nodes. Within just a single node, you have executable script files sitting directly alongside data properties stored in JSON. And you've got event handlers right there in the node too. This means the system encapsulates both storage and execution within a single dynamic JavaScript kernel. There is absolutely no separate storage engine spinning on a disk far away. The node literally is the logic and the state combined. And this encapsulation enables what the source materials call script as UX. Because queries and scripts are essentially merged into a single unified execution path, the database just functions as a local command router. When an event triggers, the embedded scripts execute locally, prompting the database to programmatically self-modify and grow. This is huge because it completely bypasses the need for massive schema redesigns or heavy database administrator intervention when your app needs to scale. It offers immense real-world relief to engineering teams.
All right, part 4, structural isomorphism explained.
Okay, we're going to take a slightly deeper dive here, but it builds perfectly on what we just covered. The crucial point here is this concept of structural isomorphism. In plain English, it means that the shape of your program and the shape of your data are the exact same thing. Because the instructions are executed through the exact same structure where the data is stored, the code's execution path and the data's retrieval path become mathematically identical. And the payoff is that this completely eliminates the overhead of serializing data to send it between separate runtime nodes. At the core of this is a fascinating mathematical framework referred to as Pythagorean metal. By applying a scale symmetry base exponent, where variables c, b, and a define specific structural coordinates, the system actually models data and execution as a continuous mathematical property. It's really cool. It's a non-halting, self-reproducing automaton that creates an infinite stack of unique inputs and outputs. Every single piece of data has a unique mathematical coordinate, completely doing away with our old reliance on physical disk sectors to track where data lives. Moving right along to part 5, LIFO and absolute truth. So how does this mathematical architecture practically handle state verification? Like, how do we know what data is actually true, and quickly, without searching a whole massive database? The secret here lies in the number 0. Initially, a lot of folks thought blockchain and on-chain trees would rely on FIFO, first in, first out structures. But HSDB strictly pivots to a LIFO, last in, first out structure for its state contracts. Because the very last item to go in is the first item to come out, you unlock incredibly efficient single-entry bookkeeping. You only ever need to query index 0. To put this into perspective, let me give you a highly relatable analogy from our sources. Think of this engine like a really incredibly efficient bouncer at a busy nightclub. This bouncer absolutely does not care about the entire line of people wrapping around the block. They only need to look at the ID of the single person standing directly in front of them, right at index 0. By strictly checking that one most recent entry, you instantly get an immediate mathematical proof of state. You guarantee absolute digital truth without having to drag your system through a massive chaotic history of past transactions. Finally, Section 6, eliminating the network bottleneck. So what happens when we put all this together? This is the massive payoff of this entire architectural paradigm. By shifting away from physical disk guarantees to that continuous mathematical property we discussed, and utilizing that strict LIFO indexing, the system achieves O of 1 memory scaling. What that means in reality is that no matter how gigantic the database gets, the time and memory it takes to verify the current state remains perfectly constant. For read-heavy scripting workloads executing untrusted scripts, you're getting near zero latency, absolute system isolation, and massively reduced cloud costs. It's a total win. When we zoom out and view the entire industry landscape, the contrast is super stark. While MongoDB decoupled the storage engine onto disk and serverless fully decoupled compute to the point where it's totally ephemeral, HSDB brings them back home into a homogeneous unit. Code and data reside together in a single JavaScript kernel. It resolves the integration friction not by breaking things further apart, but by pursuing total efficient coupling. I want to leave you with a really fascinating implication of all this. The creator of HSDB, Kyle Smith, actually comes from a background in music copyright law. He views code not just as functional, boring instructions, but as a dynamic, creative asset, very much analogous to a musical composition. So think about this. If code and data are now mathematically unified into a single isomorphic entity, how does that redefine the boundaries of intellectual property? The HSDB patent is actually designed to serve as a legal framework to protect code as it transitions into open source models, functioning much like royalties for songwriters. It is a profound thought that shows exactly how deep architectural shifts can ripple out to redefine entire industries. Thank you so much for joining me on this deep dive today, and I highly encourage you to keep exploring these fascinating paradigms.